So, couple lab 3 things. If you notice, there's like take 3 screenshots showing the firewall rules from each interface. So if you notice, what I did was took the document for the pfSense lab and then just reused it. So this does not apply to Palo Alto, right? Because you actually can't. Well, I guess you could filter it down. In Junos, though, this is still somewhat relevant. I guess it depends on how you filter it and whatnot. I always filter it per from zone when I look at firewall rules. So in my mind, it still works, but there's lots of ways. So yeah, if you did the Palo Alto one, you're not obviously going to have 3 screenshots from it. I mean, I guess you could take 3 screenshots of the same thing, but that's not necessary. So that's what's going on there. And then the other question was the whole title bar thing. So I used to have a screenshot standardsy sort of thing, but in the end, if you were going to show me, I don't know, let's say the thing says, show me your WAN interface. What I want in the screenshot then is something like, close to that anyway. Something that would go up and include the actual very top title bar, like title bar, Windows title bar.
But we can't see it on your very well.
Oh, is it cut off? Well, luckily, if it's cut off on the screen, I took a screenshot, so we should be able to look at this.
I don't think you got the name in it though.
Yeah.
Oh yeah.
Oh yeah.
Yeah.
Oh, that name.
That's what I'm going for. And any guesses as to why that is a requirement? Because it has your name in it, so you can't just take screenshots of your friend's VM and send it in. And I know there's lots and lots of ways you could Photoshop this and all that crap, but at a certain point, if you're spending more time working around doing the assignment, then... And then if there's any suspicions, I can easily just log in and look at... I think it shows for you guys too. It should be show fewer things, but there's a logs button right there. So if
Never noticed that before.
at any point I'm like, did you? Cause sometimes usually what happens when people Photoshop these, not that anyone ever has, but it'll look funny. So I'll just go type your username in the logs and be like, oh, I can see they've been logged in for a total of 3 minutes. And then that's pretty obvious. Then we have an awkward conversation. So that's what I'm going for there, just to clear up anything else. The other one is taking pictures. Maybe here's the one that I wrote for another different class. This is my other pet peeve. Please don't do this. See my screenshots right there. But see you get 3 displays and you took a screen. Please don't do that. Please try to crop it down, so that I can see the title bar and what's really going on. Or just the exact thing in the middle. Please give me the title, stuff like that. So that's what I'm going for. Or this one is also kind of irritating when it's submit 3 screenshots. You're well, it shows all 3 right there. And then I'm looking around it. And it's I get that the info is all there. But I'm scrolling through 90 of these. So when I've kind of one of those break my train of thought and slows things down. I know it's me being whiny, but that's what I'm going for. It's just anything to make it go a little quicker so I can get feedback quicker.
And PDF.
And yes, preferably PDF, because then, not that Word is a terrible application, but it just takes a bit to open it. Whereas if you're got a screenshot inside of the PDF, I can zoom quickly on stuff and zoom around. So it's purely all easy accessibility stuff for me, but then I can usually get through stuff a little bit quicker. If you submit a Word doc, I'm not going to lose my mind, but I will have a little brief sigh when that happens. So, yeah.
As you're waiting for it to load up.
Yeah, as I'm waiting for Word to load up, and not that it's slow to open, my computer's pretty fast, but
I tried to avoid getting the sign
still.
disappointment. So.
Yeah, what I'm going for is all the little subconscious things that make me go then I don't even really think about it. You don't want that when someone's grading stuff, So, anywho, what I'm going to complain about today is NAT, is basically how this goes. We have, what does NAT stand for? Network Address Translation. NAT is a necessary evil. Why do we have NAT?
Because IPv4 addresses were run out.
Yeah, that's why we use NAT now, is because back years and years ago, we realized, like, oh, bummer, this whole internet thing actually caught on, people are using it, we're going to run out of addresses. So without NAT, probably about 15 or 20 years ago, we would have ran out of IP addresses then. Whereas now, when are we going to run out of IP addresses?
A very, very, very long time.
Well, I guess in our current system anyway, we ran out about 2 years ago. Yeah, for IP6, yeah, it's going to be a very, very long time, which would be funny because 50 years from now, we're going to be like, oh gosh, why did we make this stupid IP6 system? We ran out, presumably. But either way, that's what NAT is currently being used for. So this will come back to play depending on the devices that you have actually played with. NAT is not a firewall, and a firewall is not NAT. There is one instance, there's one very special NAT circumstance where it sort of accidentally makes a firewall. But it's not an actual firewall, it just breaks the flow of traffic that you don't want. So it, like I said, accidentally makes a firewall, but that's not its purpose. So there is a situation where that happens. But I say this because a lot of, again, rant about consumer devices, they're all evil. So if you have a little blue Linksys box at home and that's been your only firewall like know-how and you've played around with NAT and firewalling there, that's not how the rest of the world really works when you leave your house. So just bear in mind when we start to do this, and if it gets confusing, it's because it's super different. And that's, you know, if you've only played around with like your consumer firewall at home, it's going to be different and it will be new. So, but that's okay, right? That's why we're here. So there's also a little like rant I had. I was talking, I think it was with Halverson, and it was like the more and more I've learned about stuff, the more and more I like find myself inept or just incapable. Because it's like the more you learn, you end up like learning 2 things, and then you learn there's 6 things you still don't know. So every 2 you learn, every 2 you know, there's 6 more you don't know, and it's just this curve of the more you know you don't know. So there's lots of crazy NAT stuff. So don't worry if this is new, because what you're going to discover is 6 more things you didn't know all along the way. So in the end, all NAT does for us is takes a packet and basically is like a find and replace function, is honestly all NAT's doing. If you've opened up a text editor and find and replaced something, that's what NAT is doing, only in a packet. It's going and looking for one IP address and replacing it with another, and maybe replacing a port, sometimes. But for the most part, packet hits a router, typically. NAT is a router thing, but we port it to firewalls because it just sort of mostly makes more sense to have it there now. But it is a router concept where we're just replacing pieces inside of a packet. So when it comes to replacing pieces inside of a packet, what if it is a packet that is doing encryption stuff? Like let's say it's a TLS, like a secure web traffic. Does it matter for finding and replacing data in there? Because is the data, when we look at that kind of a packet, like you browsing your Gmail, that's encrypted, right? Mm-hmm. When we are finding and replacing bits of those packets, is the IP address and port encrypted? It's not, right? So that was another one I wanted to like sort of trick question, right? So when we find and replace data inside of an encrypted packet, that's actually okay most of the time. There's an instance where it's not. But when we're sending out encrypted data, or like Gmail, something that's SSL or well, TLS encrypted, the source and destination IP address, those aren't encrypted. Why not? Yeah, like every router between you and Gmail needs to be able to read that part of the packet. So the rest of it, I can't read, right? Same with if you're browsing the internet and you're doing everything in your web browser encrypted. Can I see what websites you're going to and what you're doing on them? If it's all encrypted.
stuff.
It's hard. What can I figure out? I can figure out what server you're going to, right? I can figure out the IP address you're going to. So if your IP you're going to is owned by Google, yeah, I'm like, well, doing something on Google. But nowadays, Google's so big that that's hard to actually, like, are you watching YouTube or browsing, checking your email? What is it? But, so I can figure out what server you're going to. I can get a pretty good guess of what you're doing. But I don't necessarily know. I can figure out if it's something at Google, something at Facebook, shopping on Amazon maybe. But can I see that, like, you're shopping for a kitten calendar? No. But that's just the thing to keep in mind when we're finding and replacing bits inside of a packet. So we're not going to, like, blow up the packet. The only instance where we would blow up the packet is if it was a VPN packet. We'll eventually get to VPN stuff in this class. But when we're doing VPNs, we take the whole packet from, like, potentially layer 2 all the way through your application and stuff it inside of a bag called VPN, and we put another address on the outside of it. So that way it can look like your layer 2 network is extended across the internet. All those layer 2 packets are bagged up and shipped across the internet and encrypted. If you somehow monkeyed with those, then that'd be a problem. But talk for another day. So the long time ago in a router far away, so there was a time, and this is one of those, like, again, I'm just going to complain about NAT for an hour. That's really how this is going. NAT has a purpose, and its initial reason why we had it was to convert one batch of IP addresses to another. So if you think about it, if you change your IP scheme at home, is that a big deal? It shouldn't be too big, right? Because everything probably at your house is all DHCP. You just go around and reboot everything, and life would be pretty good. Let's say, and I don't have a reason why, but let's say DSU for some reason is like 138.247, because we own that whole block. What if we just decided that's no good anymore? We want something different. So again, I don't have a reason, but let's say, because this happened for some reason. I guess my biggest guess is, like, I bought your company, and I wanted you under my block of IP addresses and not your block of IP. That's my biggest guess. So someone buys DSU and says, thou shalt not use 138.247. You're going to use 137.248, which I think is ironically super close to what SDSU's IP block is. So just, 40 miles north. But anyway, is it going to be easy for DSU to re-IP all of our devices? No, like, it's pretty simple for us to re-IP, like, all of the computers, laptops, and stuff are here, because those are all configured with DHCP, right? But think about all of the other stuff. Like, someone's going to have to stand here with a remote pointed at that projector, and it's going to be like the positive experience of entering your Netflix password on a TV. Because you have a complicated password, and you're like, okay, because your TV always comes up with a keyboard, but it's in alphabetical order, and when you're typing your password, your mind doesn't work alphabetically, right? Did you ever notice that? That's just another little rant as a side. Whenever there's... Yeah. So that's something that always drives me nuts, is any on-screen display pulls up letters in alphabetical order. I'm like, no, a keyboard is like, I know that layout. I have to think about alphabet. Like, where's the B going to be? Probably not B, but... Anyway, that would be a pain. Plus, there's all the stuff that is on our network that you just don't think about, like the stupid buttons over there to turn the projector on and off. Those have an IP address. Or controllers for thermostats across. Those all have IP addresses. So somehow we would have to go and change all of that. Every single one of those devices, and it would be just awful. We're actually going through an awful stage right now because we are re-subnetting some networks. So we're not changing entire IP blocks, but we're just moving their subnet back and forth, so stuff just fits a little bit better within our network here. And that's a huge pain, so imagine redoing everything. So instead, what you could have done is natted your network to say, like, 138.247.1.1 translates to 137.248.1.1. And your router would just flip that when you'd go out to the internet. We wouldn't have to touch the internal network. We would just kind of block it off. The only issue we would really ever run into is if we wanted to go to whoever now owned the original block. That might get weird for us. But otherwise, that's what it would do. And that was pretty cool at re-IPing networks at a basically command on a router, and it was just done. So we don't really use it for that much anymore because there's not just huge chunks of IPs sitting around like that anymore. It can still be used for something similar to this in the modern era. What would that be? Something similar to not changing the IP address on your computer, but maybe just remapping it to something else when it goes out to the internet. What's a new cool system we have that's not so backwards compatible that we're hoping people switch to? Yeah. So a kind of offshoot of this standard of the original NAT is actually coming kind of back in doing IP6 to 4 tunneling. Like if you try to get to a website that's only IP6 and you only have an IP4, that's not going to work. Somewhere someone has to translate the address for you from a 6 into a 4 or 4 into a 6. So that's sort of where this is used again. So the original purpose of NAT is sort of kind of coming back, but it's a little different. So there's that. That's what it was originally for. Then we started to ruin everything. And this is my, again, rant of NAT is one of those things that we have because we need it, but it was a Band-Aid for a different problem. It was a Band-Aid because we don't have enough IPs. Same with some folks, my other rant on NAT is the additional features we're about to talk about were initially not something that was supported in IP6. It was like that old NAT Band-Aid, that's an IP4 thing. We're leaving all that garbage behind. Well, curmudgeon type people that are like, I only understand doing networking with NAT, have fought, and the features are being brought forward, which is very silly to do when we have, I don't know what the number of IP6 addresses is, like quindazillion billion something or other, So there's that. So the official, what we're going to do is talk about the categories of NAT concepts. Then we'll switch and talk about here's what your router or your firewall is going to call that. Or here's how we will, here's a high-level concept of, we'll talk about, here's how you change IP addresses around. And then we'll go to, this is the type of button you would click in a router to make that happen. Because they don't necessarily align anymore. The other fun thing is, you suppose all vendors have standardized how they implement this? Absolutely not. So it makes it even a bigger ball of fun. So, starting off, IP masquerading is something that DSU does not do, but you probably do at your house. When you are browsing the internet, can I figure out, say you browse to my website, can I figure out the IP address on your computer? Specifically. No. Because the IP address on your computer is probably, I'm going to roll the dice and guess, 192.168. Maybe 1 dot something. Is probably what it is. Maybe it's 100 dot something, or you changed it around. But either way, it's probably 192.168. Or it could be 10 or 172. That's all you have for options. So I know it's one of those. So, but me as a web server, I'm not going to see that, right? I'm just going to see whatever your outside IP address is. So no matter what you do from a layer 3 standpoint, you could have many, many devices on your network all communicating with my web server. I don't have the ability to see it as multiple devices. I see one IP address coming to me. You could have 1,000 things on your home network, and I'm not going to be able to tell. I mean, if I'm a web server, I have other tricky ways of telling. But from this standpoint, that's what IP masquerading does. So this is the area where we brought NAT forward to solve the IP4 crisis of every device on your network needs an IP address, but we can't give every device on the internet a public IP address because we quickly would run out. So that's why we have the blocks of 192.168 and 172's. 172 is a weird range, and then the 10s, right? Those are IPs that can only be used inside of your house. What happens if one of those IPs gets out onto the internet? I guess we'll talk about that. So what your router does when we are doing IP masquerading is basically, in a sense, intercepts the three-way handshake of TCP. That's also why, remember when we talked about firewall states? Talked about there is a kind of state mechanism for UDP, even though UDP isn't stateful. The reason why firewalls have a sort of, kind of state mechanism for UDP is because of NAT. If it weren't for NAT, then your router wouldn't care, or your firewall wouldn't care. But in the end, you have, like when you go out to Google on port 80, there's your destination port of 80 because you're going to their web server, right? What other port do you have? If you have your destination port, what's the other kind of port in the packet?
Source port.
The source port. What's the fancy word for the source port? Starts with an E.
Ephemeral.
Ephemeral, there we go. So we've got our ephemeral port and our destination port. On our computer, the ephemeral port is used to keep track of what? When a return packet comes back.
Where it should be sent to.
Yeah, what actual process? I mean, literally what memory buffer to dump it into for Firefox to, think about it. Our router, though, is going to use ephemeral ports too. So when we go out to, hey, here's our IP address, 168.1.123. And our ephemeral port is something like, oops, that's too many. There we go. Not that it matters. But either way. So when your computer wants to go out to the internet and you're not using NAT, who do you hand the packet to? You have to hand it, your computer has to hand the packet to someone before you get out to the internet. Who do you hand it to? You hand it to your router, yeah. So what your router is going to see is, your router sees, we're going to pretend that this is Google's website, even though it's not. What IP address is this? Yeah, it's Google's DNS service, but 8.8.8 is a cool IP, so we're just going to go with it. So your router sees a packet that has a source of 192 and a destination of 8.8.8. If your router is not using NAT, it's going to hand it off. It's going to hand it to your internet provider. And assuming your internet provider doesn't have these goofy IP spoofing RFC things enabled, will this packet, I guess despite whatever I said about your ISP, will this packet make it to Google? So can this IP address go on the internet? Yeah, so it can't, but it can't because we said so. Not because, is it a valid IP address?
Mm-hmm.
Totally. So this packet will actually get to Google. Unless your ISP blocks it, which it should do. But assuming that doesn't happen, this packet will actually hop, from Midco over to wherever it's going and eventually get to Google. Google will receive the packet, and what's going to happen when Google tries to reply? Well, at this point, yeah. When Google 8.8.8.8 tries to send a packet to, because it's going to send the response, it's going to send it to 192.168.1.123. Where's that in terms of the internet? Is that going to be associated back to you at your home? Oh, that IP probably, I don't know, is probably in use somewhere at Google. So the packet will fail to return. It will actually get to its destination, but it won't be able to get back. No one will be able to reply to it. So that's why NAT is really, really important. But like I said, what should happen when we hand this packet over to your internet provider should look at the packet and see, oh, the source IP is this? Yeah, you can't do that. To that point, not that DSU uses NAT, but we actually have a firewall rule that's like drop source IP address of not 138.247.0.0 slant 16, the destination to anyone on any port. Why would DSU put that? So it seems a really backwards firewall to make. Should our firewall ever hand a packet from inside to outside that's from, so keep in mind this is a knot, so this is an inverse. So should we ever hand a packet off that's not from 138247? No. We have no business routing a packet out. And that's a big deal when it comes to organizations that speak BGP. What's BGP do? Yeah, it's a routing protocol. It allows you to announce, if you would like to get to this subnet, come here. So it's possible, if you speak BGP, to actually send out and just dream up subnets. The BGP system is like pseudo broken because of that, because anyone can just make an announcement, and depending on how you configure stuff, the internet will just be like, sounds good. So it's actually happened before to where it was like the western portion of the United States, there was an invalid Chinese BGP update went through to where all of the routers of that part of the US thought the most efficient way to get from one side of San Francisco to another is to head to China and back. So BGP is a really, like, it's what the internet is based on, but there's all sorts of, like, you can spoof IP addresses and stuff like that because of how it works. So organizations, there's a lot of interesting ways, but like, I applied for a grant one time through National Science Foundation for like infrastructure-y stuff for DSU. And one of the rules when I applied for the grant is that we actually had to prove we had a firewall rule like this in place. So it would actually prove that, or we had to show the National Science Foundation that we're making an attempt to deny any spoofed IP addressing coming from DSU. And if we didn't, NSF would just be like, no, we're not giving you money. To heck with you. So, I mean, there's not official ways of doing this or enforcing this because it's the internet. There's no traffic cop. There's no one that owns the internet. But there's other ways of like, I want NSF money, so I make sure we had the rule. So that's how that goes. Anywho, that whole thing aside, all the stuff I just talked about is how it doesn't work, right? It's how it does work what would happen if we don't use NAT. What really happens is we go, your router will receive the packet, router sits here in the middle, and says, okay, before I hand this out to the internet, I'm going to change this to be like 96 dot something dot whatever, whoops, not that, dot 6, colon, probably a different ephemeral port going to 8.8.8.8.8 colon 80. So what's your router really end up doing here? It takes this packet right here and all the data in it. It does a find and replace, puts this in here, and then hands it to your internet provider. Where did this IP address come from? Or where would it come? I just dreamt it up. But from a practical sense of your router, where would your router get an IP like that from? From your ISP, yeah. Your internet provider is going to give you a public IP address. You have one, most of the time, to go out on the internet. So your ISP is going to give you that. Your router is going to be like, oh, yep, this is my outside IP address. I need to take everything on the inside and rewrite it to be this. So it sends it out on the internet. Can Google reply when we get here? Does it know how to get back to here? Totally. It gets back to the router. Now, when we were back here, what's this ephemeral port used for again? On your computer? Ephemeral ports tell us to send data to what? To a particular process, block of memory, something like that. When we're here, we use this ephemeral port for something totally different. Your router sees traffic coming back on the ephemeral port. What does your router now do when it sees traffic on that ephemeral port? Yeah, it converts it back. It says in it basically has more or less a spreadsheet saying, oh, this ephemeral port, oh, that ties back. It basically is kind of like taking this ephemeral port and just going like, comma over here. So when the traffic comes back on that ephemeral port, it goes, oh, I need to rewrite this and send it to the .123 computer on that port. So in the end, your TCP ports end up getting mixed around all the time. Why would the router not, typically anyway, do that? Why would it not use the same?
You can tell what port is being used on the computer.
So we can tell what port's being used on the computer. So we have a potential like security conflict. Because you could actually start to fingerprint weird stuff like that. We don't want you fingerprinting things like that. That's one reason. How did this computer come up with this number? Just pulled it out of thin air, right? It just dreamt it up. It has some sort of process by which it figures it out. What if we have two computers on our network? What if we have something crazy like this going on? What if both computers randomly choose the same ephemeral port? And we're wanting to use the same. So A, we could fingerprint the computer, but then B, from what's going to happen when we have two computers trying to use the same ephemeral port and the router doesn't make its own up. It can't distinguish the traffic between the two. So that is why your router would really have something like this going on. And that's why your router like changes or remaps the ephemeral ports. So the router would have something like this on the table. Does that make sense? It's actually one of the few times I wish I had my stylus-y thing to draw on the screen because I draw little diagrams and pointing at stuff. But yeah.
So one net setup can basically handle like as many ports are available, like 65,000, whatever it is.
Yeah, so let's go on the other extreme. Let's say your network, like let's take your LAN subnet, for example, and pretend it's like 192.168.0.0/16, and let's say you filled it full. So how many IP addresses would that be in use? Slant 16 is about how many? I think it's that many. 65,535. I think is a slant 16. So what happens to our router now that's trying to generate ephemeral ports on the fly, assuming every computer only makes one connection out to the internet? If we only make one connection, it is theoretically possible we'll be okay. Theoretically. But is that going to be the case, really? No. So this is where IP masquerading can cause problems if you have a really big network. Do networks of this size exist? All the time. Because realistically what can happen is, instead of slant 16, it's probably more like a slant 20. And there's maybe not 65,000 computers, but let's say there's, oh, I don't know, even 1,500 that are just doing a lot of stuff on the internet. So if we get those 1,500 computers and they generate 100 sessions a piece, how many is that? Add 2 zeros. Do you have that many ephemeral ports? No. So what you end up with in weird instances, and this is, there's a lot of reasons why DSU can't use a Linksys router as our edge router. I mean, the one being it's 100 meg and we have like a 5 gigabit connection to the internet. That's one reason. But the other reason is that Linksys router only can have one public IP address. It's really not its fault. It's a home device. But in the case of DSU, if we were using NAT, we would need something like this going on. We would actually need a pool of external IP addresses that were just used for IP masquerading. So we could roll over. Totally a thing that happens. Previous company I worked at, we used reverse DNS entries and stuff. So sometimes I'd be browsing the internet and do like a what is my IP, and it'll tell you like a name as well. Like your IP is, if you do it at home, it'll be like IP wrote backwards dot like clients.midco.net or whatever, like something like that. DSU won't do anything because I erased all those records, but at work it would be like gw1.company.org. Sometimes I'd be browsing the internet and I'd find that my public IP address, as far as wherever I was checking, had changed, and it would resolve to like gw3.company.org. Really, was I going out of a different router? I don't know. I don't think so. I was just using a different IP address to go out on the internet. So it was a company that was big enough that had to rotate through multiple public IP addresses. So that's a couple of the weird things that happen when you start to use NAT. Now, obviously, if we have 150,000, or no, it's 1,500 computers going on, our ratio is still way better as far as conserving IPs, because we have 1,500 computers, but we're only using 3 public addresses here. So utilization's still nicer, but it still causes some problems. This is also one of the reasons why, assuming you're just doing NAT with a router, sometimes you need a memory upgrade. Like, you can go online and find a RAM upgrade kit for like a Cisco router. Because if your network is big enough that you're not so much worried about bandwidth or throughput, you just have to keep track of all of these NAT translations, you might run out of RAM. And similar to these problems here, if you run out of RAM and you can't make another entry, just like in our stateful firewall, if you can't make another entry, what happens to that next connection? Just gets dropped or something, I don't know, blows up somehow. It doesn't work anyway. So,
Does it disappear?
yeah, exactly, it just disappears. So, that is kind of the one concept of how NAT works. The next one is, instead of taking, doing multiple IP addresses to one, multiple internals to one public, we can do it another way, where we would take individual internals and individual external IP addresses and map them. So this is kind of like the old school original system. Any guesses as to why we would use a system like this? So sometimes, if we're this system, the Masquerade, is like what we basically always use on client computers. If you go at home, that's what you're doing, is IP masquerading. This system of natting is the type of NAT we would use maybe in our DMZ for our publicly accessible servers. So instead of having many IP addresses behind one public one, if you have a server that's running a website and you want people to get to the website, they need to know an IP address to get to. If you want to run another web server, so you have another physical machine also using port 80, can port 80 go to 2 systems at once? No. So you'd have to have another IP address to get back to them. So that's where we use one-to-one NAT, is usually anyway with servers, so that we can tie an individual public one to an individual private one, like so. Make sense? This one's a little less crazy. Then the last one, see the kitties are back.
Yeah.
So one cat, many kitties, is one-to-many. So this concept is kind of like when we're doing masquerading, only the other way. And we'll talk about that. There's many words, or many like terms you can call this, and it just depends on the vendor and all that good stuff. So what this does in a one-to-many system is we would take, I didn't delete my see, I, on the fly, did ASCII diagramming in the earlier class. So anyway, what this would do is take this system, and this system, tie it behind one public IP address. This, like masquerading, also makes a firewall, but there's an additional feature here. because the idea is now what we're actually talking about is traffic going this way. Here we'd have tubes coming in. So we're talking about outside traffic coming in. Well, when outside traffic comes in and hits this IP address, where does it go? So that's why this one makes a firewall accidentally. Not on purpose. It's not really a firewall. It's just that NAT breaks the routing of the packet. When this computer, just like masquerading, wants to go out the other direction, what happens to the packet? Yeah, it gets moved to this one and away we go, right? So what we do instead is, this is for, I would say basically hosting services on the cheap, which you can do this like magic little combo at home on your home router, because you could have this system here sitting there running HTTP, this system here running SMTP, it's going to run email for us. Oh, I'm going to get my spacing off now. It's just the problem with ASCII diagrams. Then this system here is going to run Telnet. Probably not, but either way. Let's pretend for a day we're going to run Telnet. So when we get a packet from the internet with a destination of 24.220.181.123 and port 80, you get the picture that the tubes are coming. So on port 80, our router, sitting right here, knows where to send the packet to. Where's it going to send it to? To 123. If it's on port 25, it's going to send it straight across, and if it's on Telnet's port, so 23, I think. I think Telnet is 23. Uh, 23, yep. So if it was on 23, it'll send it down to this machine. So that's how we get our hosting services on the cheap. This is also how, if you go at home, or if you have tinkered at home with something like this, running Windows XP. Oh, thanks.
So helpful.
There we go. So on our whatever device we have at home, we look and we notice that when you go to forward ports, it's not asked, the only thing it asks us about is the inside IP address. So there's something missing here. It's asking us about only the inside IP address. It's not asking, it's only asking one question about ports, I guess is what I'm trying to go for. When we go, why is it not asking about the destination IP address?
Doesn't care.
Why doesn't it care?
Because you decide.
How many public IP? I guess that's what I'd say. Why isn't this asking about multiple public IP addresses? Yeah, this home router can only have how many external addresses? One and only one. It's a home device, right? It's not meant for that. So that's one thing that this is missing. This can't handle multiple public IP addresses, so we can't do one-to-one NATing with this device. We also are limited a little bit in our port overloading or our one-to-many, because if we take this particular rule, like let's do something weird instead. What if we did something like 4321? Could we send that here? Does that work? From the concept of what NAT's doing, what's NAT doing to the packet? It's just doing a find and replace. It doesn't care. NAT makes no difference at all. Now, is this device going to care? this device is going to see a packet going to not 123, but to what port? That's all this web server is going to see is a packet going to port 80. The only one that's really going to care is like when I open up my browser, I have to, what's my browser? Browsers make assumptions. You'll notice if you try to go to like, oh gosh, now I'm trying to struggle to like, I want a not encrypted website. Every website I go to is encrypted now. Maybe DSU. DSU encrypted? No. Nah, it's not. So if we go to dsu.edu:80, what's my browser do? It's like, no, that's dumb. You don't need to put that there. So our browser's making assumptions that everything we want to do is on port 80. So the only weird thing about doing this goofy NAT configuration to go to a website is that anyone that goes to the website is going to have to go like 4321. And in this case, the web server's like, no, I'm not replying to you on that port. Did we do the talk of like real browsers? Like if I try to go to port 22, Firefox is going to be like, go away? Okay, we'll make sure we did, yeah. So there are, from a technical sense, so let's talk OSI model. At what layer of the OSI model did this message happen? Is it a router that gave me the middle finger? Which would be layer 3? No, that's a higher layer than that. Yeah, the application, like Firefox, said, no, you're being dumb. Thou shalt not browse a website on the SSH port. So that's what we have going on. I already talked about that, I'm pretty sure. Oh, yeah. So no matter what you end up doing on the internet, your router is keeping a table of all these entries, and we'll take a look at what that's doing. And then there's also the whole concept, like I said, NAT ends up making a firewall sort of, kind of, on accident. That also gets tricky because when we come back to this device is doing, when it's saying port range forward, it's doing NAT for me, and it's making firewall rules for me, all at the same time. It's making assumptions, and for a consumer device, that's fine. In a, what I would call big kid firewall, they're totally separate things. Even pfSense merges them together a little bit. pfSense, when we go to make a NAT rule, there's going to be a thing at the bottom of the page that's like, do you want me to just auto-magically do the firewalling for you? Whereas pfSense and every consumer device are the only things that do that. When we go to Juniper or Palo Alto or Cisco or any commercial device, just because you make a NAT rule saying find and replace packets, that does not allow the packet through. So in the case of like hardcore firewalls, there's actually processes. There's like a NAT process running. There's a firewall process running. When we set up a NAT rule, the packet comes into the interface and gets handed to the NAT process. The NAT process find and replaces stuff inside of the packet. Then the fresh packet gets handed to the firewall process. And then the firewall looks at it. So that's kind of how these end up working in firewall land, and they're different. So remember, just because you make a NAT rule doesn't mean you're allowing traffic through, unless it's your home firewall. So in this case, what we basically end up doing, if you've heard the phrase like, I need you to forward a port through the firewall, that's that one-to-many NAT that we were doing. That's taking an outside thing, forwarding it through, and that's, so there's two ways you can look at it. We're either finding and replacing stuff, or we're being like a traffic cop and being like, oh, you need to go this way, and we'll escort you over there. So that's what's going on there. So this is where, changing gears before we talk about like how the buttons that you will see on a firewall, because there's all these different ways of doing stuff. NAT breaks things, super breaks them. So since we're going through and just finding and replacing stuff inside of a TCP header, things don't like that. So if we take VoIP and SIP traffic, so it's SIP, like Signal Initiation Protocol, I think, whereas VoIP is Voice over IP, they don't necessarily like when you hit a VoIP router and to distribute it out to a phone network, they don't necessarily enjoy their packets being just changed on the fly. That might mess something up, especially if they're going out to the internet. Also, I don't know how many people are doing like true FTP, like native FTP, but the real FTP protocol has been like broken since NAT came out. If you've used an FTP server for something, you were going around this like passive mode, which was a hack around to get FTP to work. The way FTP works traditionally, what port does FTP use? Does it use 1 or 2 ports? Yeah, it actually uses 2. What 2 ports? Not that it really matters. Yeah, it's 20 and 21. So over port 20, no, I don't remember which is which. One of them, let's just say 21, is your computer connecting to the server, and that is a control channel. The only data sent over that port is commands. You're sending a command to the server like ls. What's ls going to do? List the files. And the server is going to reply back over that with, here's a list of the files. You would send a command to the server that says get file name. And the server's like, oh, they want to download this file. Then over a different port, the server is going to send the file to you. Why does NAT break that? We come back. Yeah. So we have a session going on here over, only in this case to be 21. And whoops. 21. Well, this is probably an ephemeral port. So then what this guy is going to do is send another batch of traffic on, well, no, I've written this wrong. We have a server out here, right? My whole ASCII diagram's falling apart. Let's try again. Okay, so your client, 192.168.1.1. Actually, let's do 10s because it's shorter. On an ephemeral port, too many. Still too many, there we go. Sends a thing out to your default gateway, which then nats it, which would be 10.0.0.1, and goes here. That was too many as well. Oh no, just hung out under there. On port 21. So that's our command and control. Then you all of a sudden say, I would like to get the file. So 1.2.3.4 on a random ephemeral port sends something to 10. Well, your public IP address, which would be masqueraded by this, but let's just say 10.0.0.1:20. Does your router know what to do that? Your router sits there and says, super duper unrequested traffic, and it's going to drop it. So that is why, like, if I open up FileZilla, has anyone used FileZilla before?
Yep.
Yeah. So FileZilla is pretty cool. I have my particular FileZilla. I use it for a demo of like scraping passwords and stuff. So I have all of the secure file transfer stuff disabled in this. So when you start doing like FTPS, that's a whole different protocol going on. So none of this is a problem then. But if you notice, oh yeah, see I'm getting warned about FTP over TLS is not enabled. Don't worry about that. So I get a warning inside of here that says like, you're using this over a NAT router. Basically saying, hey, that's going to break stuff. Unless you're not doing NAT or configuring specific stuff. So that's what's going on there. So NAT breaks things. We got that going for us. The next thing is like how we have all these different things going on. So actually I will say, I'm going to skip around. I'll go down to Conehead Kitty. So even like the stuff that, so there's specifically when you look at like the real technical documentation, not that anyone goes and reads RFCs for fun, but all of the stuff we've talked about is basically, I'll say, no one in the world ever uses the real terminology for NAT, which is based on cones, so hence the conehead kitty. But if you think about the direction of traffic, it's going to look like a cone or a funnel. So there's full cone, partial cone, like reverse cone, NAT. So if you go start looking at stuff like that, just be aware that there's going to be talk of cones. And at no point in any firewall or any like networking book is there ever going to be discussion of cones. They've all renamed everything. So FYI about that. Now for when we do NAT, in a firewall, there are only 3 categories in which all of the stuff relating to NAT has to be done. Static NAT is the easy one. What do you suppose static NAT is doing? Any guess? Static NAT says this inside IP, this outside IP. Both directions locked together for life. That's it. So that static NAT is basically going back to the old original purpose of NAT, to where we would remap internal and external IPs. That's all static NAT does. The traffic flows both ways, but they're tied together, they're locked together for life, or until you change the config. So that's static NAT. Source NAT is what we would use for your client computers. Source NAT is what your house is using. Source NAT says if the packet is from this source subnet, which in the case of your house is going to say, I have it right here. If your source is this subnet, then when it's going to a destination, or you'd say going out of your WAN interface, change it. Rewrite the IP address. And depending on the firewall, it's going to give you an option. Your firewall at home doesn't give you an option. It just does what it does. But that's what that does. If it's from a source, remap it to the public IP address. If you have lots and lots of devices, too many, or you'll run out of ephemeral ports, you can say, take this big subnet and NAT it to this pool of public IP addresses. Either way, that's all source NAT is. So a source NAT, ignore the DNAT boxes right now, just look as taking all of these hosts and sending them out over this one, pretending that this is an IP address right here, sending it out over this one. So lots of internal stuff going out. When we look at that, the way we determine like the packet is from source, it doesn't necessarily have to be a subnet either. It could be from a interface or a zone or something. To that end, like when we go into Palo Alto or the Juniper firewall, it'll actually give us a drop down. Are you talking about source subnet, source zone, source interface? You pick. And then they all have specific order of operations in which like one takes precedence over the other. I don't remember what they are because it would be silly to use all of them. So source NAT can be used, or you'll see different phrasing for it. So if you think about firewalls doing stateful inspection, Cisco calls it stateful NAT. There's other sorts of silly words like I have played with WatchGuard before, and the word they use for source NAT is just wrong. They call it static NAT, and that's wrong. That's as wrong as it gets. So FYI, if you see that. Like Microsoft and F5 call it secure NAT. Why do you suppose they come up with secure NAT? Because it sounds fancy. And can anyone out on the internet figure out this IP address? Yeah, so that's why they call it secure NAT. pfSense calls it outbound NAT, which also makes sense, right? When you have this traffic going out, do it that way. The outbound, though, is like there's some bizarre circumstances to where thinking of it from an outbound perspective messes up your mind. So think of it from, we're going to take traffic from this source and do stuff with it. Hence, it's source NAT. Next one is destination NAT. So destination NAT is going to take, if we have, usually where this is going to get used, traffic on the internet has a destination and port that matches. So the packet is going to this particular IP port combo, or maybe just IP. Then we're going to rewrite the destination IP to be something else. So that would be where you would take, we're going to rewrite the public IP address to the private internal IP address of our web server, and then drop it off on that interface and ship it off on the inside of our network. So destination NAT is generally used for hosting multiple servers on a particular IP. So similar concept of, we have traffic coming in to this particular IP address, we go, oh, it needs to be switched over to that. So here's the, if you didn't use static NAT, and this diagram is not using static NAT, consider, let's pretend all three of these hosts are web servers, just for the sake of saying. When you enter in this IP address and browse to the first web server, you're going to take this IP address and you're going to hit this system. When this system, so new scenario, let's say some silly IT guy or gal logs into this server and decides from the server they're going to check their Gmail. Which, is that a good idea? No, that's a stupid idea, but people do it. When this server goes to browse the internet's going to see it from this IP address. So we do all sorts of, like, this is where NAT, like, I guess at the high level you see it gets confusing, because we have in servers on an internal IP address, but when they go on the internet, they're coming from IP1, but when people on the internet want to get to it, they go to a different IP, so you end up in this weird merry-go-round kind of thing. So usually for destination NAT, if you see other names for it, it's going to be port forwarding or something like that, is what that's usually called. So, talked about the cone kitty. There's one other NAT problem that exists. So, I have this whole scenario. So, basically what happens is, let's pretend DSU is using NAT. Is there a time in which you want to get to DSU's website for something, or something on there you need? So you're going to request dsu.edu. What IP address are you going to go to? Are you going to go to the public IP address or the private IP address of our web server? The public one. Even when you're here on campus, you're probably going to go to the public one. One of these ways of getting around this NAT problem is if we ran two sets of DNS servers, one for inside, one for outside, and that's silly. But that's one, organizations do that sometimes. But it's not real common. So inside of the network, you're going to go to the public IP address of DSU's web server. Sounds good. We're using NAT. Bad news, I guess. We're using NAT. So what's going to happen is, I'm going to change this diagram around. So that's the actual web server. So, and let's say this is you on the internal. Oh, actually, I screwed that up. Here, we're going to put 138.247.115.250. And here, I'll put 1. Okay. I might end up making another diagram out of this. So, what happens? You, inside of the network, say, I would like to go to 138.247.115.250. Does your computer have any idea that that IP address or that server that you're really trying to go to is really just next door? Yeah, it has no idea. It's just trying to go to this public IP address. So, okay, who do you hand it to? The router. The router looks at this packet and says, right here, 138.247.115.250, that has a NAT translation. When people are going to that destination, rewrite the destination to be 10.2.2.20. DSU's web server sitting there seeing the request come in, so 10.2.2.20 gets the request coming into it. And here's the catch. At any point, did you leave the network? Did you leave to go out on the internet? No. So at no point did the source NAT rule hit you. Your source IP address of the packet is still this private address. Okay, so keeping that in mind, the web server receives the request, replies, life is good. But the problem is the NAT never gets undone because it was inside. So what ultimately happens is you asked 138.247.115.250. You asked that IP address for a website, or you sent a SYN to it. The router dinks with the packet, hands it to the server. The server receives this SYN and says, okay, I will send a SYN or a SYN-ACK back. It replies, but it replies to what IP address? It replies to your private internal address. The router receives the reply. Is there any reason to do NAT? We have a private IP talking to a private IP inside? No, I just route the packet. So what happens is you ask for, or you send a SYN to this, and you get a response from that. They don't match. What's your computer do? Drops a packet. So this is where one of those like NAT being bad, this is like the core problem that NAT ends up causing for us, is when you try to go to local stuff, NAT breaks it. So you can like go back to pfSense. pfSense has a checkbox you check, and it just kind of guesses and figures it out most of the time, and it's just correct. Otherwise, for this to actually work, you would have to make individual firewall or individual NAT rules that now do source NAT from one internal network talking to another internal network. So your choices are to run 2 DNS servers or have 2 whole sets of NAT rules for inside people or external people. This is actually, the IA lab uses NAT, and this problem exists. When I am inside of the IA lab and I want to go to vCloud, I cheat and use 2 DNS servers. But for me, that's not a big deal because how many people are inside of the IA lab browsing it? It's just me. So I don't really care. Like there's some stuff that doesn't work. If I try to go inside of the IA lab to try to go to like the ISO repository thing, this super doesn't work. And I don't care because I can just whack file server and just grab the file anyway. So it doesn't really matter to me. But there's some goofiness that NAT ends up creating for us because of all of that. So yeah, this is the other thing. We already talked about that we can hide. So this is something that DSU of long ago, I'll call it a different network administrator ago, for some reason blocked 3389 going out of DSU. Why would people want to use 3389? It's a remote desktop, so it's built into Windows. Now I wouldn't, just FYI, not at home. At home I would not recommend just opening 3389 up to the internet. Probably don't want to do that. But what students would do is open it up to like the DSU subnet.
Doesn't RDP only work with your connected if you're on the same network? Microsoft RDP? I thought that was a requirement.
No, you can do it over the internet. The new one calls it like network level authentication or something. It's basically just handing you a TLS certificate. So yeah, when people blocked or when DSU was blocking this for, again, I don't know why. DSU, do we allow port 80 out of our network? Yeah, we do, because you can go out to websites, right? So what people would do is on their home routers, take the incoming port 80 and NAT it to their desktop to 3389. So as far as like identifying traffic at the port layer, the firewall was just like, oh, they're browsing a web server. When the packet would get to their router at home, they would translate it over into remote desktop. So a weird hokey thing. But that brings us to the next conundrum, is up until NAT, if you were doing something on port 80, what were you doing? Basically pretty much always guaranteed you were browsing a website, right? Or you're doing web sort of things. Or if it was port 25, you were sending an email. Is that the case anymore now that NAT exists?
Not necessarily.
Not necessarily. So that's where we will eventually get to the point where we start to talk about application identification stuff, because we can't use ports to actually identify what you're doing anymore. We use ports now to just be like, well, this is the framework in which it was built upon, so we just have to do it. But there's more goodies that come up with that, which we'll eventually get to. So, any questions on stuff thus far? Nothing? All right. Everybody have a happy Tuesday.
Thank you.